Dear students, welcome to our YouTube channel PCM Academy. Today I will solve some question based on IIT Jam Physics, and first let us start with mechanics. Okay, so the first question that is asked in 2005 in Jam paper. Okay, so the question is that a solid sphere of mass m and radius a is rolling with a linear speed v on a flat surface without slipping. The magnitude of the angular momentum of the sphere on the surface is. So you can see that here there is a rolling motion, that means there is the combined rotation and translational motion. Okay, so let us suppose that here is a sphere of mass a, suppose this is a sphere of mass m. Okay, and linear speed is v, so that means we can assume that the linear speed is the speed of center of mass. Okay, so this speed is v, suppose, and suppose it is rotating in this way. Okay, its radius is a, okay, and its mass is m. So whenever there is a combined rotational and translational motion, so we have the formula for angular momentum, total angular momentum L, that is equal to angular momentum about center of mass, that is L center of mass, plus angular momentum, that is m into r cross v. Okay, here this r is actually, if you talk, this is as the our reference point bow. So this r is the position vector of the center of mass actually with respect to this reference point, and that is obviously here a actually. And you can say the angle between a and v is 90 degree. Here you can see. Okay, so what will be here? So L center of mass is the angular momentum about the center of mass, and that is nothing but I omega. And these two vectors in the same direction, because this r cross v is also along the axis, and L center of mass is also along the axis. They are the axial vector. So this is the angular momentum term, the r cross v, and this is also the angular momentum. But this angular momentum, this L center of mass is the angular momentum about center of mass, that is nothing but I omega. So we can add these two vectors simply because they are in the same direction. So the magnitude will be L is equal to nothing but L center of mass plus m r v sin 90, because angle between r and v is 90 and r is nothing but a. So L center of mass is nothing but I omega simply, plus I is the moment of inertia, plus m instead of r we can write a, so it will be m a v. Okay, now what is I? I is the moment of inertia about center of mass, and for solid sphere it is 2 by 5 m square. So we have nothing but 2 by 5 m square. And what is omega? Omega is nothing but actually, as here is a pure rolling, so v is equal to omega r, and instead of r we can write a, so omega is equal to nothing but v by a. So this will be just v by a. Okay, so this will be v by a plus simply mva, you can write in this way. And here, so it will be 1 a will be cancelled out, so it will be 2 by 5 m v, we can write this as small m because we use small m, so it will be just 2 mva plus mva. Okay, so it will be 2 by 5 plus 1, that will be 7 by 5 mva. So this will be our final answer, magnitude of L. Okay, so that is 7 by 5 mva. So option B is correct. Okay, so this is a very good question. Sometimes it can be asked instead of sphere, they can ask for a disk also. So in that case, just this moment of inertia expression will be changed. For disk, that will be half m square. Okay, so according to the configuration of this object, the shape of the object, this will be changed. But for a circular type object, the process will be more or less same. Okay, so this is a very good question. Now let us move to the next question also. So here this is the question number 2. This question is asked in IIT Jam 2007. In terms of the basic units of mass m, length L, time t and charge q, the dimension of magnetic permeability of become mu 0. So we have to find out the dimension of mu 0 Okay, dimension of mu 0. So now how we can find out? So let me first give you the expression of mu 0 in terms of the basic units, something like mass, length, time and charge. Okay, so the best way of doing this, so let us first write the expression of F in magnetic field. You know, in magnetic field, if there is a magnetic field that is B, and if we place a wire of length L, suppose, and the current in the wire is I, then the force, the maximum force exact on this wire F is equal to nothing but BIL. Actually this is BIL sin theta or IL cross B, but for dimensional analysis we don't need to that expression, but it is just F is equal to BIL. So we can find B from here, but we need mu 0. Okay, and again we can write B in terms of mu 0 for where we know that B is proportional to actually mu 0 I divided by distance, that is x. We can write it. So if we substitute for B, so for simplicity we can write it as equal actually, because the constants are not used for dimensional analysis, so we can write it in this way also. So mu 0 will be nothing but Bx divided by I. Okay, Bx divided by I. Okay, or we can write this B as mu 0 simple, then we can find out mu 0. So it will be F is equal to just, let me write it in this way, that mu 0 I by x into I into L. Now what will be mu 0? So mu 0 will be just Fx divided by I square L. Fx divided by I square L. Okay, I square L. So this x and x will also be cancelled out, you can see, because the dimension of x and L will be same. So the dimension of F is nothing but, we know, ml t to the power minus 1 minus 2 divided by I, you know that I is equal to q by t. So it will be q square upon t square. So q square upon t square. Okay, so this t square and this t to the power minus 2 will be cancelled out, because if you solve this, you will get just ml t to the power minus 2 into t square. This t square will be moved here and divided by q square. So this will be cancelled out. So it will be just ml q to the power minus 2. Okay, so this will be your final answer. So let me check the answer. ml q to the power minus 2. So our option A is correct. Okay. Now let us move to the next question. So here this is the question number 3. This question is also asked in IIT JAM 2007. So let me give you the solution for this question also. This is also a very good question. A projectile is fired from the origin O at an angle 45 degree. So here you can see this is the origin O and it is fired at an angle, suppose 45 degree. Okay, so this angle is nothing but 45 degree according to the question. From the horizontal and at the highest point P, here this is the highest point of its trajectory, the radial and transverse component of its acceleration. Okay, so you have to find out the radius and transverse component of acceleration at this point actually. Okay, at maximum point. So what will be the radial and transverse component? At the highest point P, its trajectory, the radial and transverse component of its acceleration in terms of the gravitational acceleration g. So in terms of g, we have to find out the radial and transverse component. Okay, so let me draw the question. Let me draw actually the figure again, so you can understand easily. Okay, so this is our projectile, suppose this is your projectile. Okay, and this is the highest point P, Okay, now what is the transverse and radial component? So you know that at this point, if this is alpha, suppose let us draw a line from origin to that point. So if this is origin and this is point P, so a line from origin to that point is this. Okay, now if this angle, let us take this angle as alpha. So at this point actually, so what will be the radial and transverse component? Okay, so the radial component means the component along this direction. Okay, and the transverse means the component along this direction. Okay, but you know actually the direction of acceleration is along ground. So this will be the actual G. Okay. Now what is the component of G? So the component of G along radial direction means at this direction. So this is opposite to this direction, and this is the transverse direction. Now you know, if this angle is alpha, okay, this angle is alpha, and you know this angle is, so this angle will be just 90 degree. So what will be this angle? So this angle will be 90 minus alpha. Okay, so this angle will be just 90 minus alpha. 90 minus alpha. Okay, so let me draw this figure again so that you can understand. So let me draw this in this, so you get more space. Okay, so that you can understand easily. So this is our projectile actually. So this is our highest point P. Now this is the line joining from O to P. Okay, so this is our actually radial, this direction is our radial direction, but this radial direction is positive radial direction. If you talk about, this is along this direction, but you know the gravitational acceleration is around downwards. So this is G. So the radial component of G is along this, and the transverse component of G will be along this, along tangent. Okay, so if this angle is 90 minus alpha, you know, if this angle is alpha, I will tell you, if this angle is alpha and this is 90, so this angle will be 90 minus alpha. Let me draw another color. Okay, so suppose this angle is just 90 minus alpha. Okay, so the component of G along this direction will be G sin 90 minus alpha, G sin 90 minus alpha, and the component along this is equal to actually G cos 90 minus alpha. But you know, at downward direction, as we choose G as negative, so we can write it as minus G sin 90 minus alpha. This is minus G cos 90 minus alpha. So if you talk about the transverse component, so that is A theta, if we talk, then it will be just minus G sin 90 minus alpha, means nothing but cos alpha. Okay, so minus G cos alpha. And if you talk about AR, that is radial component, that is nothing but minus G sin alpha. Minus G cos 90 minus alpha means sin alpha. Okay, so why this minus sign is taken? This is because that the positive radial direction is this. Okay, but here G is along this direction. Okay, so if you talk about, this is actually, I have drawn this in the wrong way. This is actually, it will be along something 90 degree. Okay, so this component and this component will be 90 degree to each other. So this is somewhere in downward direction, so it will be just minus G sin 90 minus alpha. I think you are understanding. Okay, so these are the two components, because whenever you resolve some vector into two components, so this should be 90 degree to each other. Okay, they look like 90 degree to each other. So this is A theta and this is AR. Now we have to find out alpha. So if you know alpha, then you can substitute sin alpha and cos alpha, and you will get the A theta and AR. Okay, so now what will be alpha and how you can find out alpha? So you know, for the projectile motion, so let me tell you that for projectile motion, this distance is range actually, this is the range of this projectile. So from this point it will be half of this range r by 2, and this is, you know, this is actually the maximum height, so it will be h max. So you can find out alpha by using this triangle. Tan alpha will be just perpendicular, that is h max, divided by base, that is r by 2. So you can find out from here that tan alpha is nothing but h max divided by r by 2. So 2 will be here. So 2 h max by r. So now we have to find out h max and r. And you know the angle of projection. So if this is the initial velocity u, that is the initial velocity of projectile u, and this angle is given as 45 degree. Okay, so angle of projection, if you talk about theta, then it is just 45 degree or pi by 4 you can say. Okay, so we can find out h max and r directly by using the relation. Okay, so we know from the projectile motion that the expression for maximum height h max is nothing but u square sin square theta upon 2g. Okay, and you know for range it will be just u square sin 2 theta upon g. Now you know if theta is 45 degree, then obviously sin 90 is 1, so it will be just u square upon g, as sin 2 theta is equal to 1, as theta is equal to 45 degree. So we can use that h max upon r is nothing but u square sin square pi by 4 divided by 2g divided by r, that means it will be g upon u square. So this u square will be cancelled out, this g will also be cancelled out, so it will be just half into, and this sin square pi by 4 is also half, so it will be 1 by 4. Now if you substitute here, so it will be just 2 into 1 by 4, so it will be just 1 by 2. So tan alpha is nothing but 1 by 2. So whenever you get tan alpha, then you can easily find out cos alpha and sin alpha. So finally you can write that tan alpha is half. So what will be sin alpha? So tan alpha is half means if you draw this triangle, you know that if this is alpha, this is 1, this is 2, and that will be root 5. So your cos alpha will be 2 by root 5, and your sin alpha will be what we call as 1 by root 5. Okay, so you have to just substitute cos alpha and sin alpha. So if you now move here, so we have to substitute cos alpha here, so it will be minus g into, I think it is 2 by root 5, you can see here, so it is 2 by root 5, and it is just 1 by root 5. So it will be 2g upon root 5, and this is equal to nothing but minus g upon root 5. So a theta and here minus 2g upon root 5 and minus g upon root 5. So this will be a correct answer, option D. Okay, so this is a very good question that you can see. This question is asked in IIT exam 2007. Okay, now let me solve the next question, that is question number 4. This is also asked in 2007, and this is a very easy question. You can see a satellite moves around a planet in a circular orbit at a distance r from its center. That means the radius is r, radius of this orbit. The time period of revolution of the satellite is t. So initially radius is r and time period is t. Now if the same satellite is taken to an orbit of radius 4r in the same planet, the time period would be, so what will be the time period? So you know from Kepler's third law that the time period square, that is t square, is proportional to its radius. That means actually we know that this is a cube. Now here t1 we can take as t, and a1 we have r, but a2 we have 4r, and we want to find out t2 is what. Now this t square proportional to a cube, we can write in this way that t2 square upon t1 square is equal to a2 cube divided by a1 cube. Now t2 is nothing but, we have to find out t2 actually. So t2 square and t1 is nothing but t, and a2 is 4r divided by r cube. Okay, so t2 square is t square. So t2 square will be 4 cube, that means 64 into t square. Now if we take the square root of both sides, then it will be t2 will be 8t. So this will be the final answer, 8t. So I think the answer will be option A. Okay, so we will continue this series in the next video also, and if you like this video, then please subscribe this channel. Okay, thank you.